Hi, this is Alex from devstories.eu, High Performance Python Async, episode 10 of 17. Your application runs perfectly on your local machine, but the moment you deploy it to production behind a database connection router, you start seeing random crashes. The logs complain about statements that already exist, or statements that cannot be found. Nothing in your code changed. This happens because of a built-in optimization called prepared statement caching. To understand the error, we first need to look at what asyncpg does behind the scenes. Every time you send a query through asyncpg, the library automatically translates it into a prepared statement on the PostgreSQL server. Normally, when a database receives a query, it has to parse the text, analyze the syntax, and build an execution plan. This takes time. By preparing the statement, PostgreSQL does this heavy lifting exactly once and assigns it an internal name. For all future executions of that exact query, asyncpg only sends the new parameters and the statement name. This skips the parsing phase entirely and provides a massive performance boost. Asyncpg keeps a cache of these prepared statements in memory, tightly bound to the active database connection. Here is the key insight. The problem arises from a conflict between how asyncpg manages its internal connections and how external poolers like PgBouncer operate. Asyncpg assumes it has a dedicated, persistent physical connection to the Postgre server. When it creates a prepared statement, it trusts that the statement will remain available on that exact connection until the connection closes. Now introduce PgBouncer into the architecture, specifically running in transaction mode. PgBouncer sits between your application and the database. It maintains a small pool of actual Postgre connections and shares them among thousands of incoming client requests. In transaction mode, PgBouncer gives your application a physical database connection for the duration of a single transaction. The moment that transaction commits, PgBouncer takes the physical connection back and hands it to a completely different client. This breaks the prepared statement cache. Your application sends a query, asyncpg prepares it and caches it on physical connection A. The transaction ends. A few seconds later, your application sends the exact same query. Asyncpg remembers it already prepared this query, so it tells Postgre to execute the saved statement. But this time, PgBouncer routed your application to physical connection B. Connection B has no record of that prepared statement. The database throws an error saying the statement does not exist. The reverse is also true. A different client might get routed to connection A, try to prepare a statement with the same internal name, and trigger an error saying the statement already exists. The fix is simple, but requires a trade-off. You must disable asyncpg this optimization. When you initialize your asyncpg connection or connection pool, you pass a specific argument setting the statement cache size to 0. This completely turns off automatic prepared statement caching. Your queries will now be parsed by PostgreSQL every single time they run. You sacrifice a small amount of parsing performance, but your application will instantly become stable across distributed connections. If your database connections are being routed dynamically per transaction, your application can no longer assume that the database server remembers anything at all between queries. That is all for this one. Thanks for listening and keep building.